So there are two main methods by which powders are filled into hard gelatin capsule: capsule dependent method and capsule independent method. In capsule dependent method, the weight of the fill material relies on the volume of the capsule body to control the dose. It needs good flow property of the powder. In capsule independent methods, the quantity of the powder to be filled is measured away from the capsule and independently of the capsule body. Okay. So in this case, in the capsule independent method, the capsule volume does not decide the dose of the powder to be filled. So in this case, a special measuring device which actually forms a plug like of soft tablet plug, that is called as plug or a slug. So a small plug like soft tablets is formed separately away from the capsule filling machine, and then this plug which is formed is inserted into the capsule body later. After it is formed, it is inserted into the capsule body. So that is why it is called as capsule independent method. And in this case, the flow property of the powder may not be really good. It's okay, but it should have good cohesive property. The powder should have good cohesive property so that it can be slightly compressed into a plug. So the weight uniformity is not dependent on filling the body of the capsule completely. But in the dependent method, we need that the capsule body be filled completely. So let's discuss about industrial scale filling, that is capsule dependent type of machine. These machines use the capsule body directly to measure the powder. Uniformity of fill weight can only be achieved if the capsule is filled completely. So this is the principle of the capsule dependent machines. First type of capsule filling machine is the capsule dependent filling machine is the auger fill principle. Examples of this type of machine are Qualifill model 8S by Eli Lilly, Ultra 82 by Capsule Gel, and there are automatic machines which are by Shinogi Qualicaps, that is Liquifill Super. You need not remember the brand names or the makes of these machines, but the principle of operation of this machine is important. Now, in this case, the filling, since it is a capsule dependent machine, the filling of the capsules in these machines is primarily volumetric filling. What is the principle of operation? Let's discuss about the auger fill method. Now, this photograph is for the auger fill machine. Now, this is a semi-automatic machine. The capsules are fed into this ring-like donut-shaped plate. So you have an upper plate which will hold the caps and the lower plate which will hold the body. These two rings are joined together initially when the capsules are loaded. But once the capsules are loaded, the upper ring will hold only the caps. The dimensions of the holes in the upper ring will hold only the cap, and the body will enter into the lower ring. So when we want to separate the cap and the body, these two rings have to be separated so that the upper ring will hold the caps and the lower ring will hold the bodies. So once the body and the cap are separated, they are this disc, the ring shaped plate is holding the body, is placed on a turntable here. You can see this. Okay, this is a turntable, means it rotates. This table turns round and round in a circular fashion. So this ring holding the body is placed below the hopper holding the powder. The powder to be filled into the capsule body is forced using this auger mechanism. You can see this helical type of agitator is called as an auger. That is why the name of the machine is called as auger fill machine. The plate containing the bodies, that is the capsule body, is exactly placed below the hopper. So the powder is forced into the capsule body by the auger. And the plate revolves. Please remember that this plate revolves so that all the bodies which are held in this plate will get filled. Few set of bodies will come down under the hopper, they'll get filled, then the plate will rotate and keep doing so till all the capsule bodies are filled. The fill weight is controlled by the speed of the auger, the speed of the turntable. So these two will decide the fill weight. Okay, so fill weight is decided by speed of the auger and speed of the turntable. How long the capsules remain below the hopper for filling, that also is important. So that is what is decided by the speed of the turntable. The capsule bodies have to be filled completely for uniformity of fill. Okay, so the fill weights achievable by capsule dependent machines is higher than that obtained by automatic independent machines, because the body is overfilled, and then the total internal volume of the capsule is used. So the extra amount, because we are filling the capsule body completely, but there is some overfill, so that extra amount is scraped off. This is the principle of auger filling machine. Now coming to the next type of capsule dependent machine, which is the vibratory fill principle. Vibratory fill principle. Osaka OCF 120 uses a vibrating plate in the powder ball. This is a powder ball. There is a vibrating plate. And this bowl has a mesh floor. Iske either here at the bottom, you have a mesh sieve-like thing. So this vibrating plate is actually pushing the powder through the mesh into the capsule body. The capsule body is held in this disc. So this disc, you can call it as a plate which holds the capsule body. Okay, so the body is in, or you can call it as a holder which holds the capsule body. So this is again rotating. Okay, please remember how we saw in the earlier auger fill principle, the capsule body holding plate rotates. So similarly, this plate also rotates here. The cavities with the bodies so cavities with the bodies are overfilled and raised up against a metal plate. So the cavities are holding the capsule body are raised against a metal plate to push the excess powder out, and there is a scraper system which scrapes the excess powder. The system works well with dense free flowing material. Please understand, whenever you are using capsule dependent machines, you should have free flowing material. So after the excess is scraped off, the capsule and the cap and the body are locked together. So they are joined. So you can see the capsule body is pushed with a pin into the cap of the capsule. Okay, so this is a joining stage. So you have first filling stage, then weight adjustment. So the excess fill is removed with the scraper. So that is the weight adjustment stage here. And then finally joining of the cap and the body. So these are the two types of capsule dependent methods, that is auger fill and vibratory fill principle methods. Then coming to capsule independent machines, that is independent dosing systems. They are also called as piston tamp principle machines. So piston tamp machines are fully automatic. They are fully automatic, in which pistons tamp the individual doses of powders into plugs, which often resemble soft tablets in consistency, and eject the plugs into the empty capsule bodies. So what are you doing? You're forming a plug first and then transferring this plug. Physical transfer of the plug takes place into the capsule body. So this is an independent type of machine where the weight uniformity is not dependent on filling the body of the capsule completely. This can remain as partially filled capsule. So here basically there are two types of capsule independent dosing systems. One is called as the dosater and the other is called as tamping finger and dosing disc system. Let's discuss about dosater machines. These are the most widely used machines. Dosater machines are very widely used. They can be intermittent motion or continuous motion. The figure here shown is for intermittent motion machines. Now this consists of a dosing tube. You can see this is a dosing tube, long tube, dosing tube, inside which there is a movable spring loaded piston. So this is a piston and it is spring loaded. So this piston forms a variable volume inside this dosing tube. If the piston height is adjusted to a higher level like this, it will accommodate more of the powder inside. And if it is lowered, a lower volume will be occupied by the powder. So it's a variable volume chamber what is created by the piston inside this tube. The tube with the lower end open is immersed into this powder bed. So this is a chamber which holds the powder. So the tube containing this piston is immersed with the open end down, and the powder enters into this variable powder chamber. Once the powder is accommodated here, a certain force can be applied with the help of piston so as to form a soft tablet type of thing that is called as the plug. So you need to apply a compression force with the piston to form a soft tablet that is called as plug. Now, once this plug is formed, the assembly is raised from the powder bed. It is taken out and positioned over the capsule body. Now, this position here, you can see here, this is a bushing which is holding an empty capsule. Once this assembly is raised and brought to this point, it is positioned over the capsule body. The powder plug is ejected. So this is the powder plug which is ejected into the capsule body by the moving piston. So piston is forcing the plug to enter into the capsule body. So this is the ejection stage. Here the plug is ejected into the capsule body, after which the capsule is closed. The weight of the filled material can be adjusted by altering the position inside, as we discussed here. You can adjust the weight of the powder by positioning the piston height inside the tube. Or you can change the depth of this powder in the chamber here outside. Either you change the depth or you can adjust by changing the piston position. Usually both combination of both is used to adjust the amount of powder being formed into the soft tablet. Suppose if there is a missing capsule here in this plate, okay, there is no capsule. So in that case, the slug is ejected in such a way that it avoids being carried into the complete capsule. So with the filled capsule, this slug will not pass on as empty slug, a slug without any capsule. So that there is a sensor here which will sense that the capsule is not available here. So that can be an error sometimes. Here the bushing can be without the capsule, but there is a sensor always to sense whether the capsule is there. Then only that ejection will take place into the capsule. Otherwise, the other mechanism is like, yes, due to the sensor, it will detect that the capsule is not there. Then the plug will be ejected somewhere else. Okay, there is a assembly which will collect the slugs when the capsules are not detected here. Capsule body is not detected here. So following ejection, once the capsules are filled, the capsule body is closed and the ejection of the capsule takes place. Filled capsule takes place. Now after this bushing here, you can see this called as bushing, where the capsule body is held. So all these bushings are cleaned by a combination of vacuum and air. So this is about the dosater mechanism, which is a capsule independent method. Now coming to dosing disc and tamping finger machine. This is the next type of capsule independent machine. Dosing disc. So this is a disc. You can see this. This shaded region is the disc. This is a dosing disc. This is a tamping finger, or it is also called as tamping pin. So the name, as the name suggests, dosing disc and tamping finger machine. So these machines are intermittent in motion. This is a dosing disc which forms the base of the powder filling chamber. This is the chamber which holds the powder. This gray is the powder, okay, powder bed, this gray portion. So the dosing disc, this is a dosing disc which forms the base of the powder filling chamber. It has up to 6 sets of machined holes. Okay, this dosing disc has 6 sets of machined holes. So these are the holes: 1, 2, 3, 4, 5, 6. So these are the 6 sets of machined holes in the dosing disc. Now the powder in this chamber is fed is auger fed from the supply hopper. So there is a supply hopper which will keep supplying powder in this powder bed, in the hopper, from the hopper into this powder chamber. So there is an auger in that hopper which will force the powder out and it will get collected in the powder chamber. These tamping pins or fingers are made from stainless steel, and they stand correspondingly vertically upwards, up above the ear. These are actually held on a holder, and these tamping pins exactly align with the holes in the dosing disc. Okay, so there are 6 sets of holes in the dosing disc, so you'll have 6 sets of tamping fingers also. Now, once the machine is indexed and the turret is stationary, okay, once the machine is indexed, indexing means the tamping fins are oriented over the dosing disc holes, exactly over it. Okay, so that is the indexing of the machine. The turret is stationary, means the whole assembly is not moving. Please understand, this dosing disc also keeps rotating. So the whole here will come to the second stage, and from the second stage, it will move to the third and fourth and fifth stage, and finally it will reach the transfer station. So the same hole in this pin in the dosing disc will keep moving. That is why we say that is a rotating disc. Okay, dosing disc is rotating. So once the machine is indexed, the turret is stationary. When this assembly is stationary, it is not moving. That time the tamping fingers or enter, or they are lowered into the powder bed. Okay, so they go across the powder bed and enter into the dosing disc. Your holes are there now in the dosing disc. So the tamping finger is pushing the powder from here into the dosing disc. Similarly, once this stage is over, this hole moves to the second station where the tamping finger is adjusted at a different level. So more powder goes inside. Okay. Now from this stage, if the same hole moves here, then that, as you can see, the station 3 tamping finger height is much higher. Okay, so more powder can be accommodated here. So you can see the powder buildup or the plug is formed in stages and not in single motion. Okay, so this when the dosing disc rotates from one position to the other position, yes, so since it is rotating, the powder gets built up from station 1 to station 5. This is how the powder, that is a plug formation, takes place in stages, and it is consolidated or it is pressed with this pins. Okay, fingerprint, these are the fingers, right? So the tamping fingers are pressing the powder, so it forms a plug. This plug, which is formed in series of tamps, it is not formed in one tamp, it is formed in series of tamp and not in a single motion. So how you have in dosater machine, the plug is formed in single motion, right? But here in the tamping finger tamp filling mechanism, you have the plug which is formed in different stations or different stages. So once this plug is formed, the dosing disc are the next station will be the transfer station. Here, once the plug is formed, this plug will be ejected in this transfer station into the capsule body. This is the capsule body here. So once this plug is filled into the capsule body, the subsequent stages of joining of the cap and the body, and further stages of ejection of the capsule from the machine, all that will take place. Okay, so the excess powder is removed from above the cavity by a deflector plate. Here also you have a deflector plate, where you can't see in this figure, but there is a deflector plate which will remove the excess powder out from at this stage itself before transferring into the capsule. The cavity is then positioned over the capsule body and the plug is ejected later. Okay, so the plug is ejected at this stage. Lubrication of formulation is important whenever you are using either tamping finger dosing disc method or the dosater method. The formulation has to be lubricated effectively. Why? Because there is constant movement of these steel parts. There should be no powder adhering on these tamping fingers. Okay, then otherwise there can be non-uniformity on of API in the capsule. So content uniformity problem can take place due to the sticking of the powder on the tamping finger. Similarly, in case of dosater, you have pins there, right? Pistons. So those pistons also can get coated with the drug. So you need to have lubricant which will prevent the powder from adhering on these steel pistons or the steel tamping fingers. So lubrication is important. Also during ejection, this plug which is formed should be smoothly ejected. So the lubricant will help in reducing the friction at that stage also. So this is about the tamping filling machine. Now, once the filling is done, as I said earlier, the locking takes place. Body and the cap are locked together. Hmm? So that is how. And here, when you're opening the body and the cap, you have a vacuum assisted opening of the body. You can see it in this diagram. So here, in the vacuum assisted capsule opening, your vacuum is applied at the bottom of the capsule. But once the capsule is filled, then you have the pin can just push the capsule out. Okay, so this is how the mechanism of capsule filling takes place. Thank you.